Hello, my name is Alex Granley. I'm a second year mechanical engineer, and today I'm going to discuss an innovation in mechanical engineering that has taken place and is helping the lives of Albertans and Canadians overall. Specifically, it's an innovation that occurred in aerospace engineering, which is a part of mechanical engineering in many ways. Basically, it took place in the late 1990s, and it currently helps the RCAF and RAF with fueling procedures and with their jet fuels, and it helps other air forces around the world. A little background: in the late 80s and early 90s, a lot of air forces began phasing out the JP4 fuel due to safety regulations and the danger that comes with transporting the fuel. It had a very low flash point and was very low viscosity and was very volatile overall, so it was difficult to transport safely and easy to combust overall. So at the time they were looking for new sources to manufacture, as manufacture for the JP4 went down. The manufacturing of the JP8 fuel increased, and the use of the JP8 fuel was thought to be the next big step for the industry. The reason it is safer is it is less volatile, has a higher viscosity, higher surface tension, and a much higher flash point, which makes it much safer to transport. However, it makes it more difficult to use in the ignition engines of the aircraft. So as far as the CT-114 plane, the tests were going to be conducted was a flashpoint test in mid-flight. Initially the F5 was used to test, however the engine was slightly less, it was a lower energy ignition engine and wouldn't achieve reignition mid-flight. However, in the CT-114, the test conducted involved a pilot flying the plane at high altitude, mid-altitude, and low altitude, turning off the engine and attempting to reignite the engine while in mid-flight and gliding. The test pilot conducted these experiments in the worst possible conditions and at very low atmospheric temperatures, as it would be more difficult for the engine to achieve the reignition temperature, considering the flash point of the JP8 was higher. In the end, the CT-114 was capable of reignition with the JP8 fuel, and as well as the JP5 fuel, which was a different test. And it was determined through the thesis, and was accepted that the JP8 was a conceivable replacement for the JP4 fuel, which was very low in demand and was not being manufactured. And during the 90s, many air forces continued to replace the JP4 with the JP8 fuel. This was a big step as far as safety goes in the Air Force. Now most air forces around the world use fuel besides the JP4 for safety reasons, especially in the Western Air Forces. So innovations like changing fuels in aircraft are very important for the safety and well-being of the citizens that the Air Force is trying to protect, and overall is a very big success. I'm running out of time, but my sources can be seen below, and I'll also show them here. Thank you very much for watching my video. I hope you learned a little something about the replacement of hydrocarbons in jet fuels.